epicentral distance is 200 kilometer. Epicentral distance is, let us say, 230 kilometer. And the amplitude is 23 mm. The ground movement, the ground displacement is 23 mm, and epicentral distance is 230 kilometer. Can you tell me this the moment, this magnitude, Richter magnitude? Please calculate and tell me. How 70 participants? Only 73 participants. How come 73 participants? Please calculate and tell me. Anybody is calculating, or let me skip? Am I audible?
Yes, sir.
Why are you all silent? Pardon? Please calculate and tell me. See here, you have to first use this formula. Okay. So your A is equal to 23 mm. Okay. So don't forget, I said the value is in 23 mm, but here you have to be very careful. It should be substituted in micron. Okay. So 1 mm is equal to 1000 micron. So you should substitute the value here 23,000. Right? Understand? So here A should be 23,000. So now you calculate this value. Now you calculate this value and substitute here. This value should be substituted here. Okay. Then again, this is equal to 230 kilometer. Equal to 230 kilometer. So 230 kilometer is
4.98.
Pardon?
4.98.
4.98.
So
There is this value. I mean this value m del, right?
no, sir. Final M.
So that means m del. You mean m del. This one.
No, sir.
So what about this m?
Sir, M del is 3.735.
M del is 3.75 or m is how much? How much is m?
Sir, 4.36.
4.36.
There are many values. How? So log 10,
Final length is
23,000.
4.36, sir.
Yeah, this is 4.36, correct? Okay, so you substitute 4.36 here. That is 1 point. And another one, 100 divided by 300. Sorry, 300 or 230. 100 divided by 230.
30.
Yeah.
Sir, 4.985.
3.73, sir. 3.73.
1.73. So minus 4.36. 4.99. Right? See, here,
Yes,
this
sir.
is, yeah, pardon?
3.74.
No. Here, this is minus.
3.74.
This is
The
minus.
final M del is 3.73, sir.
Final M del is 3.74.
How
Oh, yes, sir.
2.7 will come? This is
So
minus
4.36 plus
this is
4.36 plus
4.36.
1.73 times log.
Yeah, this is 4.36, and here it is minus. Oh, minus will be plus, right?
Plus, sir.
Okay, fine.
Point
Okay.
seven.
Okay. Okay, fine. So how much you get? 4.3.
734.
3.734.
3.74, same only, sir.
Okay, okay. So another one, a surface wave magnitude. Another one, surface wave magnitude. So based on the surface wave characteristics, also we can classify the. We can define the magnitude. So that formula is ms is equal to log a plus 1.66 log del plus 2. Okay. So here this is where a is as usual, it is the maximum ground displacement in micrometer. Okay. And del is the epicentral distance of the seismometer measured in degrees. Okay. So del is the epicentral distance in degrees. So degrees, if you how to calculate degrees. Yes. Okay. So this one, it should be measured in degrees. So that means your value should be, your calculation should be like, suppose let us say 230 kilometer. So 230 divided by the diameter of the earth. Okay. So the diameter of the earth, that is 12,700 kilometer into 360 degree. Diameter of the earth into 360 degree. So this will give you the distance, the epicentral distance in degrees, right? Okay. So after that you substitute on this formula, so you can get the value of surface wave magnitude. And next one, body wave magnitude, again the same case. Okay. So here Gutenberg has given another next formula to find the magnitude for body wave based on body waves. So MP is equal to log A minus log T plus 0.01 del plus 5.9. A again the magnitude. T is the period of the P wave. Okay, so it is the time period of the P wave, and del is again the same epicentral distance in degrees. Here the time period of P wave is 0.8 second. Calculate the local surface and body wave magnitude for the following data. The local is nothing but the Richter magnitude. Okay, so ML. So that is why that formula is given ML. Here this one ML. Okay, so ML, that is local magnitude, and another one surface wave magnitude. Then body wave magnitude for the following data. Time period of P wave is 0.8 second. Time period of Rayleigh wave is 21 second. Epicentral distance is 1150 kilometer for surface waves and 180 kilometer for body waves. Epicentral distance like that. So based on these the data, you try to calculate these values, MS, MP, and ML also. Okay. So another one, moment magnitude. This moment magnitude is based on amount of rupture developed during the earthquake. Okay, so based on that only we can calculate this moment magnitude. So the formula is this one, MW, that is equal to 2/3 of log 10 M0 minus 9.1, where M0 is nothing but seismic moment. This seismic moment is equal to this one, M0 is equal to mu into D into A. Okay, so where mu is the shear strength of the rock, mu is the shear strength of the rock, and D is the dip or the slip measured, okay, the measured slip, that is D, and A is the area, that is the rupture area, the physical dimension of the rupture area. Okay, so that will give you the seismic moment. So M0 is equal to seismic moment. That value is equal to the shear strength of the rock, that is mu, into D is nothing but the slip measured, okay, and A is nothing but the rupture area. So based on that, we can find out this moment magnitude value. Most of the earthquake, the scale, most of the earthquake magnitude are measured in terms of this moment magnitude only. Okay. So they calculate the moment magnitude of an earthquake with the rupture area dimensions of the length, the rupture area dimensions of the length 50 kilometer and width is 25 kilometer, and the slip, that is the dip value, that D value, that is 2 meter. Assume modulus of rigidity mu is equal to 3.5 into 10 power 10 Newton per meter square. Okay, so modulus of rigidity, that is the shear modulus, the shear strength of the rock. So now you substitute in this and calculate the value of MW and tell me. 50 kilometer and 25 kilometer and into 2 meter. Okay, so you have to substitute 50,000, 25,000 into 2 in this formula. So 50,000 into 25,000 into 2, and mu here is 3.5 into 10 power 10 Newton per meter square. Okay, and you will get one value, that is m naught. Then you take the log of this value, then minus 9.81 into 2/3, that will give you moment magnitude. So 50,000 into 25,000 into 2 into,
So what is the mu value once again?
pardon? Mu value 3.5 into e power 10. So log of this value 19.9 into 9.1. So 7.22 is coming. How much you get? You tell me.
7.22, sir.
Pardon?
7.22.
Yes, correct. Okay. So 50,000 into 25,000 into 2 into this value 3.5 into 10 power 10. For this value, you take log, you will get a 19.9 something like that, right? And subtract 9.1 from that value and take 2/3 of the entire one, you will get 7.22. Okay, so that is the moment magnitude value of a particular earthquake based on these data. Okay. And classification of the earthquake, it is based on location, interplate earthquake, intraplate earthquake, and based on epicentral distance, local earthquake, regional and teleseismic earthquake, based on focal depth, that is shallow depth earthquake, intermediate depth, that is focal depth is nothing but from ground surface to the focus. Okay, that focus point or the hypocenter point. So that distance, if it is up to 71 kilometer, then it is shallow depth earthquake. If it is 71 to 300 kilometer, that focus depth is 300 kilometer, it is intermediate depth earthquake. And next one, deep earthquake. Okay, if it is greater than 300 kilometer. Based on magnitude, micro earthquake of magnitude is less than 3. Then it is micro earthquake, intermediate 3 to 4, 5 to 5.9. It is moderate. Strong earthquake, it is 6 to 6.9. Major earthquake, 7 to 7.9. Greater than 8 are greater earthquake. Great earthquake. Okay. So like that we can classify the earthquake. And the direct effects, one is ground shaking leads to structural damage. Ground shaking leads to structural damage, landslides, mudslides, disintegration of the foundations, and the liquefaction. Okay, so these are all direct effects. The liquefaction you know very well. Okay, locations of these events. Yeah.
Sir, we want subtitles.
Okay.
You can mute them, sir. You can mute them.
160 room no.
Subtitles.
6 style. Oh, okay. You paranormal power. You less symbol.
I muted them, but I hope it's muted. Okay. Okay. The direct effects are structural damage, landslides, and mudslides, disintegration of the foundation, liquefaction, and indirect effect is tsunami. Okay. Liquefaction we know. Okay, so it will happen in the loose soil only, loose sandy soil, particularly loose sandy soil, very fine sandy soil only. Such type of the effects will happen. So the liquefaction, what will happen inside when the soil is the saturated fine sandy soil subjected to the lateral loads, this ground shaking, the excess pore water pressure will be developed inside the particles. The pore water pressure will be increased. Okay, so you would have studied in the soil mechanics. The total stress, the effective stress. Effective stress, it is the difference of total stress and the pore water pressure when the soil is saturated. Right. So when this pore water pressure increases, the effective stress will be decreased. Okay, so when the effective stress becomes zero because of this increase in pore water pressure, so it will lead to reduction in shear strength of the soil. So when the shear strength of the soil will be also will become zero due to the effective stress values becomes zero because of this increase in high pore water pressure. Okay, so when the effective stress is zero, the entire soil mass will be becoming like a liquid. Okay, so the soil at this stage, the soil will be flowing. Okay, so because of the further ground shaking, the soil will be the soil shear strength will be reduced and it will be moving like a fluid. So at this time, the sand boiling, the soil will come upward at the surface itself. So such type of the phenomenon is called liquefaction, and the soil which come upward at the surface, that is called sand boiling. Okay? The boiling of the soil or boiling of the sand. So mainly this will happen when the ground shaking will lead to increase in pore water pressure of the soil, the sandy soil. Okay, so that is called liquefaction. And these are some of the historical earthquakes in Peru earthquake, and these are the what is called lateral spreading. Lateral spreading. Due to this lateral spreading, the ground displacements have happened, and these are the building collapses. And in Mexico earthquake and collapse of the hospital building during San Fernando earthquake in 1971. And this is the 1964 Niigata earthquake in Japan, the collapse of the entire building. You can see the full building gets collapsed due to the liquefaction effect only. The earthquake induced liquefaction causes such type of the collapse of the building failure. And this is also the same Niigata earthquake. This is called the Showa Bridge. It is called Showa Bridge. The bridge was resting on the pile foundation. Due to this liquefaction, the soil shear strength reduced. Okay, the soil shear strength reduced, and since the soil shear strength was reduced, there was no lateral support given to the pile foundations. So again, since there was no lateral support, the pile foundations failed. Consequently, the failure of bridge also happened. Then the Showa bridge also happened. So these are all some of the failure of the buildings and bridges and even soil during the earthquake. And this El Centro earthquake. This is Christchurch in New Zealand, sand boiling. This is the Bhuj earthquake. Some of the building failures during Bhuj earthquake. This is a lateral spreading of the soil. You can see the soil gone down due to this liquefaction effect only. Okay. So the indirect effects, that is the tsunami and the velocity of waves and everything we'll see next class. Any doubt? And after that we have strong motion, strong ground motion, and its ground motion characteristics. So we will see these topics in next class. Any doubt? So till now we have seen the interior of the Earth, then the plate tectonics, then that boundary movement of the plate boundaries like divergent boundary, convergent boundary, and transform boundary, and of course one more, continental drift. Continental drift also we have seen. Then the elastic rebound. So because of that elastic rebound theory only, the earthquake occurs. Okay, so during that earthquake, the vibration of the ground will be happening. Because of that vibration, seismic waves will be generated. The seismic waves are again classified into two types: body waves and surface waves. Body waves are again divided into two types: P and S waves. Surface waves are classified into two types: R and L waves. Okay, then and all these the characteristics: shear wave velocity, velocity of shear waves S waves, velocity of P waves. How to find out based on the dynamic properties of the soil. Then what else we have seen? Yeah, how to measure this earthquake? So using seismograph, and the record obtained from the seismograph is seismogram. Okay, then how to measure this earthquake, the distance, the epicentral distance. Okay, and the measure of the earthquake in terms of intensity and magnitude. Intensity, it is the measure of the amount of destruction caused to the society. So based on that, intensity is measured. Again, it is classified into four types. Not classified. Every country has its own intensity values. One is MMI, MSK, RF, and JMA scale. So we follow MMA scale of the intensity only. So here, from ranging from 1 to 12. Okay, so how it is defined? The intensity scale is given. Then magnitude. Again, the measure of the earthquake is magnitude. The magnitude is can be classified into four types: Richter magnitude or local magnitude. Based on body wave characteristics, it is body wave magnitude, and again surface wave magnitude. And the last one, moment magnitude. Okay, so the moment magnitude, the most of the earthquake measure is being given based on this moment magnitude value only. The moment magnitude you can calculate based on seismic moment value. Okay. So that is M naught, seismic moment value. It is it depends on three factors: amount of the fault area, rupture area, and the slip occurred during the earthquake, and shear wave, what is called shear strength of the rock, that is modulus of rigidity, shear modulus of the rock. So based on that, we can find out this seismic moment. Once this is calculated, you can substitute in this formula which is given by Hongs and Kamori. Then we can find out the value of MW, that is moment magnitude value. Then after that, the effects are direct effect and indirect effect. Direct effect is of course liquefaction. So there are some of the past history of the earthquake also you see. There are many building failures also there, that the building failed during past earthquake, particularly in Bhuj earthquake and Nepal earthquake. If possible, I'll try to explain in next class. Okay. So what is the reason for a failure of such buildings? Okay. So the next topic is strong ground motion characteristics. That we'll see next class.
Can you upload this PPT, sir?
Yeah, I'll